What's up, everyone? Welcome back to my channel, The Math Corner. Today we'll be covering 1.3 trigonometric functions. So let's start. Alright, so before we actually start talking about trigonometry, we should cover what degrees and radians are. Degrees and radians are two different ways to measure angles. Alright? So in calculus, the only thing you're going to be using is radians. So if you see something in degrees, you're always going to convert it to radians before you end up doing anything with it. So how do you go about converting degrees to radians and radians to degrees? Well, it's a very simple formula, actually. So for degrees, from degrees to radians, you multiply the number of degrees with pi divided by 180, and then you get the total number of radian, or the angle in radians. And then if you do, and you can do like the opposite, where you multiply radians with 180 over pi to get degrees. So that's just how you convert from degrees to radians and radians to degrees. Okay, so let's go review some of our basic trigonometric functions. This side, the longest side in a right triangle, is called the hypotenuse. The side that's opposite to the angle theta is called the opposite, and the other side that is adjacent to the angle theta is called the adjacent. We have 6 trigonometric functions. I'll go list out the first 3. The first 3 are sine theta, which is equivalent to the opposite divided by hypotenuse, cosine theta, which is equivalent to the adjacent divided by the hypotenuse, and then tan theta, which is equivalent to the opposite divided by the adjacent. Okay, there we go. Now, the next 3 trigonometric functions are just reciprocals of the first 3 that I had just written. So cosecant theta is reciprocal of sine theta, so that'd just be hypotenuse divided by the opposite. Secant theta is a reciprocal of cosine theta, which is just the hypotenuse divided by the adjacent. And cotangent theta is a reciprocal of tan theta, which is just adjacent over the opposite. So these are your 6 basic trigonometric functions. Alright, so the next few slides that we'll be covering are about trigonometric identities. So the first type of identity we'll be talking about are the reciprocal identities. Cosecant theta is a reciprocal of sine theta, right? So we can just write that as 1 over sine theta. Secant theta is equal to 1 over cosine theta. Alright? Now the next 2 are identities that use sine and cosine to describe tan theta. Alright? So tan theta is equal to sine of theta divided by cosine of theta. And cotangent theta is equal to 1 over tan theta, which is equal to cosine theta divided by sine theta. So these are your main reciprocal trig identities that you need to know. Alright, so now let's go over some of our Pythagorean identities. So, sine squared theta plus cosine squared theta is always equal to 1. That's always true. The next Pythagorean identity we have is tan squared theta plus 1 equals secant squared theta. And the third one we have is cotangent squared theta plus 1 equals cosecant squared theta. So these are our three main Pythagorean identities. However, you can rewrite them a lot of different ways. So for example, you can write sine squared theta is equal to 1 minus cosine squared theta. You can write that secant squared theta minus 1 equals tan squared theta, and cosecant squared theta minus 1 equals cotangent squared theta. There's a lot of ways to rearrange these identities, but these are the three main equations that you have to know. Alright, so let's learn a little bit about the addition and subtraction identities, also known as the sum and difference identities for trig functions. So sine of A plus B is equal to sine of A times cosine of B plus sine of B times cosine of A. Sine of A minus B is equal to sine of A times cosine of B minus sine of B times cosine of A. Cosine of A plus B is equal to cosine of A times cosine of B minus sine of A times sine of B. And cosine A minus B is equal to cosine A times cosine B plus sine of A sine of B. So these are all the addition of subtraction identities that you have to learn before you take calculus. Alright, so the last group of identities that we have to learn are the double angle identities. So the double angle identities deal with stuff like sine of 2 theta and cosine of 2 theta. Sine of 2 theta is equal to 2 sine theta cosine theta. And cosine 2 theta is equal to cosine squared theta minus sine squared theta. And you can rewrite that as 2 cosine squared theta minus 1 if you use the Pythagorean identity. And also you can write that as 1 minus 2 sine squared theta if you use the Pythagorean identity a different way. So my challenge is for you derive these two versions of the cosine double angle identity using this one. So my challenge for you is to rewrite this into that and that. That's my challenge for you. So yeah, these are just the double angle identities for you. So the special thing with all trigonometric functions is they're periodic. So sine of x, this is the graph of sine of x, all right? And sine of x has a period of 2 pi. So what does a period of 2 pi mean? A period of 2 pi means it finishes one cycle in 2 pi units. It takes, you travel 2 pi along the x-axis, and you'll see that the function sine of x has finished one cycle. The period of sine of x equals 2 pi. It goes up and back down, and then it goes back up to where we were at x equals 0, except now it's at x equals 2 pi. This is cosine of x. Cosine of x, just like sine of x, has a period of 2 pi. This cycle takes 2 pi units to complete. So I'll just write p of cosine of x. I don't want to write the full word period. P of cosine of x equals 2 pi. That's how long it takes to finish one cycle for cosine of x. This is the function tangent of x. If you look here, we can assume that the function starts at pi over 2, negative pi over 2. The function ends at, sorry. Let me retry that again. The function starts at negative pi over 2 and ends at positive pi over 2, all right? So we can assume that this is our start and this is our end. And this is one cycle because at our end, we start a new cycle here. You see that's going back up and it's gonna, I haven't included this in the screenshot, but it's gonna go up just like that. And this one will just go down just like that. So we can see that the period in this case is just pi. It's not 2 pi, unlike sine of x and cosine of x. So p of tangent x is just pi, because that's how long it takes to finish one cycle. This is a function cosecant x, which is the same as 1 over sine of x. Sine of x has a period of 2 pi, so cosecant x will also have a period of 2 pi. And if you take a look from 0 to 2 pi, we can see that the cycle begins again after 2 pi. So this is one cycle. This is one cycle. I don't have enough space to write that. But this is one cycle. And then the next cycle starts here and goes on. And the previous cycle ends right around here. The same way the cycle ends right around there. So the period for cosecant x is 2 pi. This is secant x. Secant x is equal to 1 over cosine of x. Cosine of x has a period of pi, so secant x will also have a period of pi. And we can see that if we take a dashed line from 0 to pi, from 0 to 2 pi, we have a dashed line on x equals 0 and x equals 2 pi. We see that this function begins to repeat itself after every 2 pi units. It goes up, it goes back down, takes a big U-turn there, and then it comes from up, down, and then it's going to start repeating itself again. So the function has a period, the function secant of x has a period of 2 pi. And last but not least, we have cotangent x. Cotangent x, similar to tangent of x, has a period of pi rather than 2 pi, just like some of the other functions that we've dealt with. If we look from 0 to pi, we see that the function goes from infinity and then, reaches 0 at x equals pi, and then goes all the way down to negative infinity. Wait, that is pi over 2, I'm sorry. So from 0 to pi, okay, wait, just edit that out. Okay, so last but not least, we have the function cotangent of x. Cotangent of x, let's just say it starts at x equals 0. and we have another dashed line at x equals pi. The function cotangent of x goes from positive infinity. It reaches x equals 0 at it reaches y equals 0 at x equals pi over 2, and then it goes back down to negative infinity, and then it repeats itself again. It has a cycle of pi units. So cotangent x, just like tangent of x, has a period of pi units. That's a lot of information to grasp, but all you gotta remember is sine, cosine, cosecant, and secant have periods of 2 pi, and anything with the word tangent in it has a period of pi units. So anything that doesn't have the word tangent in it has a period of 2 pi units, and anything that has the word tangent in it has a period of pi units. All right, so let's go. The last thing we'll be learning about are the standard forms for sine and cosine functions. So standard form for sine functions is a times sine 2 pi over p x minus c plus h. All right, so a is the amplitude. The amplitude is the distance from the midline, the resting position of the wave, or the midline, to the highest point in the sine function or the cosine function. That's the distance amplitude. P is the period, which is how long does it take to finish one cycle. And C is the horizontal translation. And H is the vertical translation. All right. The same thing is true about cosine functions. So we can literally just the standard form for cosine of x is very similar to the standard form of sine of x. All right. So let me rewrite that. C. The C does not look great. Let's edit that part out. So A times cosine 2 pi over p x minus c plus h. All right. So like again, A is the amplitude. P is the period. C is the horizontal translation. And H is the vertical translation. So these are all the different components of the standard form for sine and cosine functions. And that is actually the end of the video. So I hope you found this video helpful. And I'll see you next time.